Hi everyone, welcome back. Last week I talked about the discussion session with the Board of Visitors. Another question that came up in my discussion with the board members was how computer sciences plays into my research. So I thought I'd dedicate the next few videos to that question. Today I'd like to talk about human-computer interaction. That's the field in which I got my PhD, and simply put, human-computer interaction is concerned with developing technologies that are easy and pleasant to use. But educational technologies are, in my mind, a particularly interesting case. And that is because there are many ways to think about the users. For example, if you take your smartphone, you're the user. If you like it, you'll buy it. But with educational technologies, it's different. The student who's learning with the technology is certainly a user, but so are the teachers who are using it in their classes. And often, they aren't even the ones who are making the decision to buy it or not, or whether to use it or not, because some educational technologies, like the ones that I develop, are actually available for free. That decision often gets made by the higher-ups. So, in designing educational technologies, we need to take into account the goals of all of these users when we think about usability. Another interesting distinction that often gets made is between user-centered design and learner-centered design. When you think about what you do with your phone, the goal is that you get to do your tasks as efficiently and as easily as possible. So we want to minimize opportunities to make errors. Think of autocorrect when you're typing, for example. But when you're using a technology for learning, the goal is different. We actually want to make the task difficult enough so that learning can take place. Often, that means that we want to allow students to make mistakes so that we can give them feedback on those mistakes, because that is how the students will learn. This week, I actually looked back at our usability studies for our interactive Lewis component for a paper that I'm currently working on. And this makes for a good illustration of what I mean by user-centered and learner-centered design, and also the different ways in which we can think about the users. So, when students draw Lewis structures, they have to learn some important things about electrons. For one, they have to show which atom the electrons belong to. Even though in reality, electrons are shared across the entire molecules, Lewis structures serve as kind of bookkeeping devices to keep track of how many electrons there are for each atom, to determine whether the octet rule is fulfilled and whether the molecule is neutral or has a positive or negative charge. Also, students have to learn to show lone electrons as paired. Here's an early prototype of our Lewis component. So here, to add electrons, students activate a dot tool and then click on the atom to add dots, which then snap into place around the atom. Students here actually did not have to pair electrons. So we tried out this version with chemistry students, and we found that they found those interactions confusing because it was not quite clear when they clicked which atom the electron would be added to. Also, we realized that from a teaching perspective, like from the perspective of chemistry instructors, we had to change this component so that it would be clear whether students showed paired or unpaired electrons. So here's the next version. We modified the electron function so that the electrons stuck to the outside of the atom to indicate where they would be placed. We also implemented a pairing function so that the electrons stuck to each other at a fixed distance to indicate pairing. And if students did not pair the electrons, they received a message that said something like, "You're close, the number of electrons is correct, but the placement is not." So we tried this out again with chemistry students, and they found the sticking to the outside of the atom too subtle to indicate which atom the electron would be added to. And also, they actually did not like that they had to pair electrons, but instead they suggested that we automatically pair them. Now, this is interesting because this is something where we value the teaching goal of having to learn to pair the electrons more than the usability consideration that it would make the task easier for the students if they were automatically paired. So here's the next version. We added highlighting to the electron's function so that a round highlight would appear around the atom to which the electrons belonged. We also added highlighting to the pairing function for the electrons so that a rectangular highlight would indicate whether the electrons were recognized as pairs. And we added a highlighting function for correctness feedback so that you would get a rectangular highlight around the component that you had drawn incorrectly, like if you hadn't paired the electrons. And when testing this out with students once again, we found that this made it more obvious to the students what they got wrong. And obviously, along this process, we made a lot of other changes in the component, but I think that would be too much to talk about for this video. The last step in this development process was actually to integrate the component with instruction. So that is the perspective where we look now at the teachers as being users as well. So here we designed this tool so that instructors of chemistry courses here on campus can use it. So we looked at the instructional materials that they use, and then we added some supporting steps at the beginning and some explicit instruction on what you actually need to think about when you construct a Lewis structure. And we did that to align with the teaching materials in the chemistry courses. So, but what if you're a teacher in a field that is perhaps not chemistry, and you're not developing your own technologies? What can you learn from this if perhaps you're looking for interactive visualization tools online? I'd say really think about the visualization skills that students should learn. Make sure that the tool you're using allows students to make the mistakes that you want them not to make when they don't use the tool. So think about, what is it that they often get wrong when they're drawing on paper? Would the technology actually help them remedy those mistakes? And I think it's kind of funny that we often think of technologies as making things easier. But for educational technologies, we also need to think about whether the right things are left to be hard so that learning can actually happen.